Hello and welcome back. Dale VK3DWL here. Just a quick little video showing the process I go through for the printing of the ZoomSpot cradle, which I featured in the last video. I use a free online modelling software called Tinkercad. It's very basic, it's pretty easy to learn, it's got some nice inbuilt tutorials which teach you the basics on how to operate it, and then you just have to get a bit creative with how you use the elements in there to create different shapes and things like that. There are some much better 3D modelling softwares on the market. Fusion 360 comes to mind, but it's a paid subscription and that sort of thing. At the moment I'm just learning. As you can see, I've got a few models here that I've been working on. This one happens to be a drink bottle slash mobile phone holder to go on my wife's wheelchair. Just to make life a little bit more convenient, when I was working up the ZoomSpot cradle here, I actually sliced off the bottom portion of it and just printed this part only as a test piece to make sure I had all the position for the cable tie slots and that sort of thing worked out. So it's simple, very simple operating software. For those that don't know, there's a couple of different steps you have to take when processing a 3D print. First step is obviously your modelling. You export that as an STL file. That then goes into another piece of software called a slicer. There's plenty of those around. Creality, which is the brand of printer I use, have their own version of slicer. And there's a few other ones out there. I'm using one at the moment called Cura, which I'm also trialling and getting the hang of. Not sure that I like it 100% yet, but it's certainly getting there. So that's our 3D printer. Just the general basics of the model. As I said, I'm not going to go through how I built the thing because it took me probably, I don't know, maybe about 2 hours by the time I finished messing around with it. And I took the option just because I could to get a little bit fancy and model the frequencies and the labels and everything on there. And as you can see, I've got all my slots for cable ties, which is using cable ties to secure the devices at the moment. We might get a bit fancier in the future. Made a couple of hooks here for the 240 volt power supply cable that goes into the little USB block in the middle, which you might have noticed on the finished product. So what we normally do is hit export as STL. I'm not going to do that because I've got the STL file already saved. What I do need to do though, I need to go into the file and load the G-code into the slicing software, which is here. So as you see, we've got two files here. We've got a G-code file, which is the file you actually put into the 3D printer, for those that don't know, and this is the STL file. So what we'd normally do is open the STL file. Cura will automatically open for me, as that's the one I've been favouring at the moment. And once you're in, it basically gives you your file. You zoom out, 360-degree view of everything. Over the side here, there's a huge amount of parameters. Now I've already made the changes to what I want to make here to correct the problem I had. If those have seen the previous video, these upright supports here, I changed the infill density of them based on some previous models that I'd printed, and it just didn't work. The top and the base were very flimsy. They do a good job, but they're not solid like I wanted. And these upright supports are very hollow, where they should be reasonably well infilled and given plenty of structure and support there. One of the things I will do with this is I rotate the model 90 degrees to change the printing orientation. Everywhere you see that is red basically says it should have some sort of support printed in there to keep it all in situ until the plastic dries and comes off. So that's basically it. So I'd now save that, and then we'd hit the slicing program, the option here. So it does the calculations for you based on the specifications you've got in here, with your build temperature, your build plate temperature, the infill pattern and density and that sort of thing, how thick the walls are. All of that stuff is changeable. It also can make a difference to the speed of the time that it takes to print, the quality of the print, that sort of thing. As you can see, it's going to take 19 hours, 19 minutes down here, 120 grams and 40 meters of printing filament. Using actually a dark blue PLA at the moment. So normally I just save this to disk. I don't want to overwrite the other files that I've already created there, so I'm just showing you here how it all works. And then I'll just show you the printer as it fires up, and we'll wait 19 hours and 20 minutes, give or take, for it to finish its print run. For those that are boggled by the amount of time it's going to print this thing, yeah, I was too. The one thing I've learned about 3D printing in the last few months that I've been playing around with it is that of any size print, it's a slow process. Alright, thanks very much, and I'll show you what's happening on the printer shortly.
Righto, so off camera I just loaded the file onto the SD card, stuck that back in the printer. Simple, very simple interface. I don't know if you'll be able to read that on camera. Oh, there we go, that's not too bad. Sorry about the flickering. So you basically just go down, press enter, go down to print from card, select the item you want, and off it goes. At the top there you see it's got a target build plate temperature here of 75 degrees, and once that gets to 75 degrees it will start printing, heating up the extruder nozzle, and then you go. Probably takes about 3-4 minutes for it to get up the temperature, not very long, and then it will take off and start doing the print for us. Alright, so as you can see, the device has come up to 220 degrees Celsius. Makes it happy for printing of the thing. It'll do a little bit of a purge of the print nozzle. It's going to add a bit of light here because it's very hard to see at the moment in this area. Unfortunately, I'm using a dark blue PLA filament at the moment. It's really hard to get it to show up. So if we get our lighting a bit better there, as I can see, a terribly professional video production this, but that's alright, it still works. And as I said, I'm very new to any of this YouTube stuff, etc, etc. So it's going to lay down, I don't know if you can see that there, it's going to lay down a very thin brim around the print area, and that helps adhere into the plate. So I'm not going to sit here and hold the camera for the next 19 hours. I just thought I'd give everybody a bit of a look at what's going on. If those people haven't seen a 3D printer working before. It's basically just a like any CNC device, but this got a plastic extruding head on it rather than a router or a milling machine or a plasma cutter or whatever CNC devices people might be familiar with. And this is basically going to run like this now for the next 19 hours and 19 minutes. It does show us the progress on the screen there. So at the moment we're at 0%. It's taken 8 minutes for it to get up to temperature and actually get started, and it's just going to rock and roll like this. So that's it. I'll show you the finished project eventually. Once I'm happy with it, it's my intention that I will give it a little bit of a light sand up. I'm using a fairly coarse build quality just to reduce the time. The finer print that you make of these things, the longer they take to print, and 19 hours is already quite a significant little print run. So after that, once I'm happy with it, it's actually done a decent print this time without me stuffing up the variables, I'll give it a bit of a paint with some car spray filler just to fill in the print lines, A bit of a paint job, highlight the text on the front where I've modelled in the frequencies for the individual zoom spots. I use one for System Fusion, I use one for DMR. Those not familiar with the zoom spots, they are multi-modes, and you can run more than one mode on them at a time, and it will scan through the modes and just produce whatever audio it picks up at the time. But I prefer to have the two dedicated like that, and then I can just pick them up and move them and take them with me. And it also makes it easier if I know which one's on what frequency. That way, if I'm ever away anywhere and somebody wants to jump on, they're more than welcome to. Alright, so there's 19 hours to go. Give or take a few minutes. And I might post another couple of clips or something after this is all finished. Alright, thanks very much for your time.